Okay, just another example since I ran out of my 15 minutes. So I have two more examples I'd kind of like to cover with you. I've already kind of got this drawn down for my example number 5 here that I wanted to cover with you. And it's going to be, they're going to give you information dealing with shadows. And even though it doesn't create a triangle, they are like triangles. So they may say that you have this 12-foot pole that casts a 20-foot long shadow. And at the same time, your sun will have the same angle on everything. So at the same time, a building casts a 30-foot long shadow. Now, as you read through the problems, what you want to do is you want to make sure that you are putting down the correct information. Don't make your building 30 foot tall. The shadow that is cast is 30 foot long. How tall in feet is the building? So this would be the information that I am looking for. If you want to make a triangle out of it, you can, but you do not have to, because you notice that as you sketch these in, those are going to be similar triangles to each other, because this angle that the sun is coming down at is going to be the same, and the pole hopefully will create a right angle with the ground, and so will the building. So right here, what you are doing is you're just going to set up your proportion and solve. So you would have 12 over 20 is equal to x over 30. So if you just go ahead and cross multiply and divide that, you would realize that you would end up with 18 for the height of that building. Okay, besides the shadows that I just talked about, maybe they are going to ask you a question that's very similar to those first ones that we worked with dealing with perimeter, except for they're going to ask you about area. And if they were to ask you about area, sorry, I should not have that 24 there. If they were to ask you about area, they're going to maybe pose a problem to you that says the lengths of the sides of a right triangle are 6, 8, 10 feet respectively. What is the area in square feet of a similar triangle whose longest side is 15 inches? So as I look at it, I see that the 6, 8, 10 triangle is, it's a 3, 4, 5 triangle. So a similar triangle where I have the side length of 15, I can find the other two sides, because what I am doing with the 3, 4, 5 triangle to get to the 15, I double it to get to the 6, 8, 10, but I would triple the 3, 4, 5 triangle to have that longest side be 15. So 3 tripled is 9, 4 tripled is 12. So they want to know what is the area of this particular triangle. So it's going to be base times height divided by 2, and we are going to find out that it would be 54 square units, whatever those square units may be. I wrote off of the paper there from what you could see. So 54 would be your answer. Okay, so if I give you another problem, they might tell you the lengths of the side of a right triangle are 9, 12, and 15 respectively. So I have this right triangle, the side lengths are 9, 12, 15. Once again, keep in mind that triangle right there is the same thing as a 3, 4, 5 triangle. Now they are going to tell you that if the area of a similar triangle is 6 feet, what is the length of the longest side? Now read carefully. I know in your worksheet sometimes they ask for the longest side, sometimes they ask for the shortest side. If I look at this one, I see that the area of this particular problem, you are going to, or this particular triangle, is going to be 9 times 12 divided by 2. So you would end up with a value of 54. Now what they have is they have an area of 6. And if I just look at my 3, 4, 5 triangle, the area is going to be 3 times 4 divided by 2, or 6. So if they are asking me for what is the longest side, the length of that longest side would then be 5, because once again you have this 3, 4, 5 triangle. So please be careful. If they ask what is the length of the shortest side would be 3, be careful of what they are asking for. Okay, the final example, or this example 8 that I wanted to go through with you. This is going to be a problem some of you are going to look at and you're going to go, oh, I think I'll skip it because it's going to require me too much work to do. They're going to give you the 3 following figures, and they're going to tell you, in the figures below, we show 3 triangles where triangle ABC is congruent to triangle DE, not congruent, sorry, similar. They're going to say triangle ABC is going to be similar to triangle DEF, which is going to be similar to triangle GHI. Now remember, similar means you're going to have just one little squiggly mark in there. If you put equals, it's congruent. But this just says that I have enlarged them by a particular scale factor. In these similar triangles, the perimeter of triangle ABC, I'm just going to put numbers inside here, triangle 1, triangle 2, triangle 3. So they tell you that the perimeter of triangle 1, triangle ABC, is 1/5 the perimeter of DEF, or triangle number 3. So it's a 1/5 as much. And then they're going to tell you that the sides of triangle ABC, oh wait, they probably give you another piece of information. They're going to tell you that the perimeter of DEF, so the perimeter of triangle 3, is twice that of GHI. So it's twice the perimeter of triangle 2. Now another way you could say that is that the perimeter of triangle 2 is going to be half the perimeter of triangle 3. Just another way to look at it. Now what they are going to tell you is that the sides of ABC are given as 5, 8, and 12 respectively. So I'm going to go with 5, 8, and 12 respectively. Now remember, the very first example that I gave you in the first video said that if we could figure out the scale factor, then that applies to both perimeter and the sides. So if I asked you, what is the length of the shortest side of triangle GHI? So I want to know, what is that length right there? What is the length of the shortest side? Well, if triangle 1 is 1/5 triangle 3, that means that this is 5 times as much. So I could rewrite this one as well. I could say that perimeter of triangle 3 is 5 times the perimeter of triangle 1. Now I said the side lengths hold that same scale factor. So if it's 5 times as much, that means that this shortest side, from 5, I would take it times 5, and that has a value of 25. Now I know that triangle 2 is going to be half of triangle 3, because the perimeter is half of it. It's smaller, and it says that it is half of it for perimeter. So that means the side lengths hold that same ratio or scale factor, so it's going to be half of what the shortest side is of DEF. So then I find out that that side length, the shortest side in GH, is 25 halves, or 2.5. So this will end the videos that you need for similar triangles. I know you know a lot about similar triangles. Most of it that you've done as far as in class, we've worked with proportions. But this gives you a little insight on how to work through it with scale factors.